Hi. Today we are going to discuss another topic in equilibrium chapter, that is pH scale. It's a very important topic. pH value, its calculation. So many problems are there. So we can go to pH scale. Before knowing pH scale, we should have an idea about ionization in water. Water is weak electrolyte. That means water undergoes partial dissociation. H2O liquid undergo partial dissociation to get H plus and OH minus ion. These ions are in acoustic. If there is partial dissociation, there will be an equilibrium. In equilibrium, we know there will be an equilibrium constant. For water, equilibrium constant is known as ionic product of water. It represents as Kw. What will be concentration of product by concentration of reactant? Concentration of H plus into concentration of OH minus. Actually, equilibrium constant, concentration of product by concentration of reactant, but here concentration of H2O equal to 1. We know concentration of pure solid and concentration of pure liquid are assumed as 1. Concentration of pure solid, concentration of pure liquid are considered as 1. This is about H2O, weak electrolyte, partial dissociation. Its equilibrium constant Kw equal to concentration of H plus into concentration of OH minus. At 25 degrees Celsius, that is room temperature, experimentally determine concentration of H plus and concentration of OH minus in water equal to 10 raised to minus 7 molar. At 25 degrees Celsius, that's our room temperature. H plus equal to OH minus 10 raised to minus 7 molar. By substituting this value, we will get Kw equal to 10 raised to minus 7 into 10 raised to minus 7. That is 10 raised to minus 14 molar square. Okay, this is about the ionization in water. But we should have a strong idea that these values are applicable. These values are applicable at 25 degrees Celsius. That is our room temperature. If temperature changes, all this value also change. Consider, if we increase temperature, more water undergo dissociation. That is, dissociation of water increase. If dissociation of water increase, concentration of H plus increase, concentration of OH minus increase. Concentration of H plus increase, concentration of OH minus increase. Then Kw also increase. Okay, so these values are applicable only at 25 degrees Celsius. If we change the temperature, H plus changes, OH minus changes, so Kw also changes. Okay. Based on this idea, we can study about pH value. It's a mathematical term. pH equal to negative logarithm of molar concentration of H plus ion. We should have, it is simply not concentration, molar concentration. Molar concentration of H plus. Okay, pH equal to minus log concentration of H plus. At 25 degrees Celsius in water, H plus equal to 10 raised to minus 7 molar. We can substitute this value in this equation. pH equal to minus log 10 raised to minus 7. From max, log 10 raised to x equal to x. We are using this log based to 10. Log 10 raised to x equal to x log 10, that's equal to x. So minus log 10 raised to minus 7. Log 10 raised to minus 7 will be minus 7. There is another minus. So total pH equal to 7. We know value of what pH in water, that's equal to 7. If any acid is dissolved in water, HCl, H2SO, for any acid is dissolved in water, this acid generate H plus ion. There is H plus ion in water 10 raised to minus 7. If acid is added, concentration of H plus in water increase. That become greater than 10 raised to minus 7. If concentration of H plus greater than 10 raised to minus 7, that is concentration of H plus equal to 10 raised to minus 6, minus 5, like that, pH will be 6, 5 like that is less than 7. So, in acid, pH less than 7, for water, pH equal to 7. What about base? Base generate OH minus ion. So, if any base is dissolved in water, that OH minus ion combine with H plus in water. So, concentration of H plus in water increase or decrease? It will decrease. OH minus in base combine with H plus in water. So, concentration of H plus decrease. Concentration of H plus decrease means that become less than 10 raised to minus 7. Concentration of H plus become less than 10 raised to minus 7. So, pH will be greater than 7. For water, pH equal to 7. For acid, pH less than 7. For base, pH greater than 7. We should know a strong, solid idea. These values are calculated. These values are used only at room temperature, that is 25 degrees Celsius. Similar to pH, we can use another term, pOH value. pOH value. pOH will be minus log molar concentration of OH minus. Again, at 25 degrees Celsius in water, concentration of OH minus equal to 10 raised to minus 7. So, pOH equal to 7. If any acid is dissolved in water, that H plus generated from acid combine with OH minus in water. So, concentration of OH minus in water decrease. If concentration of OH minus less than 10 raised to minus 7, pOH will greater than 7. If base is added, base generate OH minus. This OH minus increase concentration of OH minus in water. Concentration of OH minus become greater than 10 raised to minus 7. So, pOH will less than 7. So, water pOH equal to 7, acid pOH greater than 7, base pOH less than 7. Similarly, we can use the term pKw value. pKw equal to minus log Kw. pKw equal to minus log Kw. Again, at 25 degrees Celsius, we know Kw equal to 10 raised to minus 14. So, pKw equal to 40. Okay. pKw minus log Kw at 25 degree, Kw equal to 10 raised to minus 14. So, pKw equal to 40. If you increase temperature, concentration of H plus increase in water, concentration of OH minus increase in water, Kw increase in water. Okay? If concentration of H plus increase, pH decrease. If concentration of OH minus increase, pOH decrease. If Kw increase, pKw decrease. So, pH 7, pKw 14, pOH 7, these values can be used only at 25 degree. If we change the temperature, pH, pOH, pKw all will change. I am leaving the derivation. We can relate pKw will always pH plus pOH. Always pKw equal to pH plus pOH. In pure water, pH equal to pOH. If pH equal to pOH, we can use the term pKw equal to, instead of pH plus pOH, that is simply 2 pH. That is 2 pH. These equations can be used only for pure water. Generally, what's the relation? pKw equal to pH plus pOH. This is equal to 40, no doubt. This is equal to 40 when at 25 degree. Okay, pKw equal to pH plus pOH, that's equal to 40 at 25 degree. But in pure water, we can always use the term pKw equal to 2 pH, that's equal to 2 pOH. To understand these things, I am going to explain a simple problem. At 80 degrees Celsius, pKw of pure water is 30. Find pH and predict nature of water at 80 degrees Celsius. Okay? At 80 degree, pKw of pure water is 13. Find the pH and predict the nature of water at 80 degrees Celsius. Since it is pure water, pKw equal to 2 pH. That's equal to 30. So, pH will be 13 by 2. That is 6.5. If we get a pH value 6.5, normally students will say that it is acidic. What is the reason? If pH less than 7, it is acidic. But here, this answer is wrong. Still, it is neutral. Why? Here, pH 7 for water have no significance because temperature is not 25 degrees Celsius, that is 80 degrees Celsius. Okay, here pH 7 have no meaning, pH 7 have no significance. So, we cannot use the term pH 7 for water. If it is less than 7, that is acidic. Still, it is neutral. We can simply explain this. If pKw equal to 2 pH, that's equal to 2 pOH. So, if pH equal to 6.5, that's equal to pOH. If pH and pOH are same, it is neutral. So, here 7 is neutral. 7 for water cannot be used because temperature is not 25 degrees Celsius. I already said 7 you can use only at 25 degrees Celsius. So this is the problem. So I am summarizing this concept. At 25 degrees Celsius, pH equal to 7 for water. If temperature greater than 25 degrees Celsius, pH less than 7 for same water. If temperature less than 25 degrees Celsius, pH will greater than 7 for water. So for water, pH equal to 7. We can use that only at 25 degree. If temperature changes, that pH also